Hi kids! So for our topic today, this will be the last topic in terms of your biostatistics and the first topic for your midterm period. Now, I am JC Luis Mandala and this will be the first time ever that you will be listening to my discussion. For your non-parametric statistic, which is our topic for today, expect that there will be two videos that you will be watching and listening since I will be dividing this into two para at least naman po may konting break kayo. And to start, so this will be our objectives. So I will not read this one by one, but just to give you an overview, non-parametric tests or your non-parametric statistical tests is a part of your hypothesis testing. So as you can observe here, most of the objectives being presented here usually starts with testing the hypothesis. And this one here are the different examples of your non-parametric test. But before we go to identifying the different types of your non-parametric test, so we need to discuss first the advantages and disadvantages of your non-parametric test or non-parametric methods. Once you get to understand what non-parametric methods are, you will be able to differentiate also non-parametric from your parametric, and then we will now go over to your different types. So as you can see here, these are just some of the examples of your non-parametric tests and actually included po yung chi-square dito sa ating topic. So kaya isusulat ko po dito na ang last na portion po sa ating discussion is your chi-square test. Chi-square, I think, or as far as I could recall, Ma'am Ella mentioned your chi-square, but chi-square is actually very broad and there are a lot of types of your chi-square. There are chi-square tests that are under your parametric. There are chi-square that is under here in your non-parametric. So you will discover that later on. Now, first of all, what is a non-parametric test? Now, to give you a brief summary, kumbaga, kung ano po yung non-parametric test, all the definitions that have been given to you during your parametric lecture, i-opposite nyo lang po. And that is already your non-parametric. Whatever the assumptions of your parametric test, if may isa po dun na hindi ma-meet, then you go directly to your non-parametric test. Kasi with your parametric test, ang dami-daming assumptions. And if either one of it cannot be met as mentioned, kung pag-check nyo po sa inyong research data or sa data na meron kayo na gusto nyo i-test, may mga criteria sa kay parametric na hindi tumpak dun sa inyong data, then you go directly to non-parametric test. So, these are the uh, the definition or for you to know if your data is needs or it is a non-parametric data. First of all, it is not normally distributed. Now, when we say not normally distributed, the first thing that should come into your mind is yung sinasabi po nating may bell-shaped curve. 'Di ba? Isa po 'yan sa na-observe natin if your data is normally distributed na nasa center yung peak and then perfect ang pagka-curve, yung bell-shaped curve nyo. Now, how do we know if it is not normally distributed? Now, one thing that could describe that your data set is not normally distributed is in terms of its uh, measurement scale or type of data. If it is a nominal or ordinal, then that is mostly not normally distributed. So if maalala nyo pa, when we say nominal, from the word itself, nominal meaning naming or meaning categorical siya. And when we say nominal, it is not actually in numbers. Diba? Naming nga siya. So, to give you an example, in terms of gender, that is a nominal category or that is categorical. And yung categories natin under gender is male or female. How about your ordinal? Ordinal from the name itself, order. Meaning, naka-scale in order or naka-rank or naka-in order yung categories mo or yung data mo. And that is what non-parametric test is all about. Another thing for you to know na kung not normally distributed, kung hindi normal yung distribution ng data nyo, is very evident yung outliers nyo. Naaalala pa po ba yung outlier? When we say an outlier, as per definition, it is a data point that differs significantly from other observations. Na kumbaga, kung yung dataset nyo nasa range sa 10 to 20, and then may nakita kayong isang number dun sa dataset nyo na nasa 50, siguro mga about dalawa lang, that is considered as your outlier. Kasi nga, most of your dataset andun na range. Kaso may naalanjoy isa, may nag-iisang data ka lang talaga na far from the range that you have set or from the data set that you've gathered, then that is an outlier. And usually, when you have an outlier, it makes your data not normally distributed. Next, it does not involve population parameters or sample population is unknown. So usually, di po natin, uh, natawag ito, we do not mind whether there is a certain population, definite population sa data. And lastly, data consists merely of rankings or classifications not based on a measurement scale. If you try to compare it with parametric, 'di ba, yung mga high order measurement scales yung ginagamit ng parametric nyo. While here in your non-parametric, that is just nominal or ordinal. So now we go to the advantages as stated in our objectives. So we need to point out what are the advantages and disadvantages of your non-parametric test. The first advantage is that your non-parametric test is very easy to understand. Easy to understand. Next, computations are easier. Fewer assumptions that have to be met, and assumptions are easier to verify. Now, non-parametric tests are easier to understand since uh, actually connected yung sinasabi dito na easier to understand sa sa other advantages pa po natin. But in terms of the computations, actually hindi nyo to ma-appreciate dito sa ating discussion since we will not be doing manual computation as we will be using your Excel. And I do hope po na na-install nyo po yung Megastat na add-in in order for you to perform your non-parametric test. Ito po kasi yung downside ng ating non-parametric test. Since it is not commonly used, so even dun po sa ating mga different na software, di po siya libre na add-in. Kaya, kumbaga, hinanapan ko lang din po ng paraan na para at least ma-appreciate or ma-hands-on pa rin po natin yung non-parametric test. SPSS will always be the best since it is a more powerful tool compared to your Excel. But then again, di po natin kasi kumbaga di po natin pwede gawing compulsory yung paggamit ng SPSS since we do not have available software for it and dapat kami kasi yung magpo-provide. So, since di rin naman po kami na-provide ng SPSS, so we will stick with Excel. And then, another advantage, as yun na nga, computations, going back, computations are easier here in your non-parametric test because konti lang yung ating tinatry compute nito. Yung usually formula na lang nga agad yung fina-follow natin. Di po natin kailangan na i-compute pa si mean, i-compute pa si standard deviation, and kung ano-ano pa yung mga dapat i-compute. Again, with non-parametric test, it is simpler. We use formula And then, ang isa na kailangan lang din po natin is yung mga chart, yung Z-charts natin if ever we do manual. But then again, wala po akong i-represent dito ng mga manual computations since, or we will just be focusing on the use of your Excel. In terms of the assumptions, as far as I could recall, parametric test ang daming rules for you to be able to tell na eto, si parametric test talaga yung gagamitin mo. But for your non-parametric test, fewer na yung assumptions, ang dali-dali pa pong i-verify. And you will learn what are those assumptions later on. But actually, meron na tayong mga assumptions na na-mention kanina. Yung dapat not normally distributed siya, dapat nominal or ordinal siya. And in terms of the sample size, usually lesser ang sample size lang din na requirement ni non-parametric test, unlike your parametric. And yun na. So, di ba, fewer and easier to verify. How about the disadvantages? So, one of the disadvantage of your non-parametric test is that they are less sensitive than their counterpart. Na kumbaga, you really need a very large difference before you are able to say that the null hypothesis can be rejected. Hindi kasing powerful ni non-parametric test si parametric. But that doesn't mean na hindi siya okay. Again, magdedepende lang talaga sa ating data kung ano yung best na gagamitin. Next, they tend to use less information than your parametric test. Like, for example, your isang best example natin dito is your sign test, which is actually one of the simplest non-parametric test. Sa sign test kasi, we only need to have the population median and your hypothesized median. And then, from the name sign test, titingnan lang natin yung each data value ninyo if above or below siya sa ating hypothesized median. But we do not check as to how much above or below that value is to the median. Kaya basta above lang, basta below lang siya. Pero kung gaano siya kababa, gaano siya kataas, di po natin siya kino-consider or di po natin siya minamind. And then lastly, they are less efficient than their parametric counterparts. So yun na nga, less efficient, less powerful siya, and these are your disadvantages. So, for this table, this actually summarizes all your non-parametric tests in which hindi po lahat-lahat madidiscuss natin due to the limitation of the software that we are using. If SPSS pa po sana ito, then most probably we will be able to cover it all. But since your Megastat only have very few non-parametric tests that we could actually process, so we will stick with that. Makikita nyo po ito sa handout. So, di ko po ito isa-isahin since along the way, madidiscuss din lang naman natin siya. So, I just want you to read it or go over it so that you will have a general or kumbaga parang dagdag knowledge na lang din for you sa kung ano tong mga test na to. Now, what is this ranking? As what I have pointed out a while ago, most of your non-parametric tests involves the ranking of your data. So later on, when I will be presenting to you the different tests, may makikita kayo dun sa Excel that could actually automatically output that could automatically rank your data. If we do manual computations, mano-mano siya na dapat irarank nyo talaga siya from lowest to highest. Then again, since you already have your software, so do not need to do it manually. Again, most of your non-parametric tests involves the ranking of your data. So ano po tong ranking? Ranking is the positioning of a data value in a data array to some rating scales. Now, when your variable or data set is an ordinal variable, then that would really involve ranking. So let us take for example, suppose ako yung judge. And then magre-rate daw ako ng 5 speakers. And ito po yung rating ko sa kanila. Si speaker A is 8 yung rating ko, kay speaker B 6, kay speaker C 10, kay speaker D, 3, kay speaker E is 1. Now, if we try to rank it, 1 being uh, 1 being the best and 10 being the worst, then ganito po yung mangyayari sa ranking natin, di ba? Since 1 is our best, then speaker E would be our first. And then, si speaker D, having a rate of 3, siya yung second, and then sunod-sunod na, and then our last would be 10 kasi nga, di ba, si 10 is our worst. So that is how you rank your data. So as simple as that. So, when we say hypothesis testing, kasi nga 'di ba, parametric and non-parametric tests are hypothesis testing. We are trying to test if our hypothesis or our claim is correct. Hypothesis testing will always involve this five-step approach. First, we need to define the null and alternative hypothesis. Second, we need to select the level of significance. Pero usually, sa maalala ko during my masters, when I was taking up my masters, dito sa atin, we rarely use the 1% na level of significance. Doon po talaga tayo sa 5%. So, if in the case na may mabigay po ako na example or yung dun sa laboratory activity nyo na hindi naka-emphasize yung level of significance, always assume that it is in 5% or your 0.05. Then select the appropriate test statistic and compute. So, of course, once you na-point out nyo na po kung ano yung test statistic na gagamitin nyo, na kung parametric ba siya or non-parametric, and then anong klaseng non-parametric, kay sign test ba siya, kay KruskalWallis ba siya. So once you selected the appropriate test statistic, then you can proceed to computing that one. And then once we are done computing and we already have the p-value, interpret now your p-value. Remember our rule for interpreting your p-value. Na 'di ba, if it is less than 0.05, then you reject the null hypothesis. If it is greater than 0.05, then do not reject your null hypothesis. So ito po yung pino-point out dito sa and make a decision whether to reject or not. And then your last step would be, of course, giving out a conclusion. So, dun nyo na po sasabihin na since the p-value is less than 0.05, then we will reject the hypothesis. So, therefore, so ano na yung null hypothesis nyo, ganun. Okay? Now, your non-parametric test have a parametric counterpart. Na kumbaga, they are the same, it's just that they are different in terms of your type of data or measurement scale. Na kung di po natin ma-meet yung assumption ni parametric, so pwede ito po yung gagamitin natin under ng parametric. So parang partner-partner lang din sila. So Wilcoxon sign rank is paired with your t-test, your paired sample t-test, then Mann-Whitney for your independent sample t-test, KruskalWallis for your one-way ANOVA, Friedman for your two-way ANOVA, and then you have your chi-square test of independence, which is a standalone. So later you would get to understand as to why there is no parametric counterpart for your chi-square. Kasi napaka-simple lang try natin tingnan kay chi-square. And then you will already have an overview as to the purpose of each of these tests. So now we go to our first and simplest type of non-parametric test, which is your single sample sign test. Now, why is it called as a sign test? Sign test literal na because we use here positive and negative signs. We point out we place a positive sign if it is greater than the hypothesized median. We place a negative sign if it is less than the hypothesized median. So, then again, i-discuss ko po muna para mas picture out nyo ano yung pinagsasabi ko na hypothesized median, positive, negative. So, let's proceed. So for your single sample sign test, it is the non-parametric version of your one sample t-test. So your one sample t-test, this one, your one sample t-test is under your parametric test. So this is its counterpart, and it is used to test the value of a median for a specific sample, or what we also call as the one sample median test. So basically, yung concern ng ating single sample sign test is the median of your population. So the distribution of the variable of interest here is continuous, and we will compare the total number of observation less than or greater than your hypothesized value or hypothesized median. So, ang gagawin lang natin dito sa single sample sign test, once we have our data set, we will try to compare it with our hypothesized median, and then ko-compute na lang din po agad natin. Kasi papakita ko lang din po yan, may mga examples po tayo. Now, as you can see here, ito po, this is how uh, we state our null and alternative hypothesis in terms of your single sample sign test. So for our null hypothesis, the median in the population is equal to the hypothesized median. So yan po yung meaning nito ha, na symbol, hypothesized median or hypothesized value, while your alternative hypothesis, the median in the population does not or is not equal to your hypothesized value. So, ganun lang po siya. Parang guide nyo na din po ito if you are going to make or if yung example nyo sa laboratory activity nyo is a type of or yung kailangan nyo i-perform is a single sample sign test. So, at least para kayong merong template as to how you will state your null and alternative hypothesis. So now we go to our example. So this is an example of your snow cone sales. So let me just read the problem. A convenience store owner hypothesizes that the median number of snow cones she sells per day is 40. A random sample of 20 days yields the following data for the number of snow cones sold each day. So you have here your data set. So at level of significance 0.05, test the owner's hypothesis. So if we will translate this one into layman's term, kumbaga kung Tagalogon or Bisayaon man nato ni, katong owner sa convenience store, iyang gi-hypothesize, iyang gihula, di ba? Alam man ang yung tag-hypothesis, it is a sana guess, something like that. Di ba napamanti una? Anyway, kalimot ko kids. Basta ka na. Iyahang gi-hypothesize na ang iyaha lagi dawng cell number of mabenta na snow cones kay naa sa 40. So mo na per day iyahang gina-count pila man gyud ang iyahang mabaligya taga-adlaw, and then mo na iyahang na-come up na data mo na day ni ang atong data. So atong sa first day na siya 18 na nabenta, then the next day 30, 39, 36 and so on and so forth. I forgot also to emphasize the kids that one difference po di ay sa inyuhang parametric and non-parametric test is that most of your parametric uses the mean, most of your non-parametric uses the median. So kaya if magwonder kayo, dito sa ating example, we are actually looking at the median, not the mean. Okay? So, the very first step that you need to do, diba, is to state the hypothesis. And this is our null and alternative hypothesis. Na, diba, as mentioned a while ago, here in our problem, yung hypothesized median value niya is 40. So that is why our null hypothesis is that the population median is equivalent to the hypothesized median, which is 40, while our alternative hypothesis is that it is not equal to 40. Etong step 2, di po nyo po ito gagawin. This is just my way of pointing out to you for you to appreciate the positive and negative signs. Okay, di ba? Sample sign test nga siya. So, saan po dito yung signs? Ito po siya. Once you already have your data set, compare it now with your hypothesized median and place a negative value if it is less than the hypothesized. place a positive sign if it is greater than the hypothesized median. Zero po yung ilalagay natin pag equivalent siya sa hypothesized median nyo. Then after you get all the signs, actually ina-average ito and such if you do manual computation. But then again, since we will not be doing that one, so let me just present to you now how we process sign test in your Excel. So, di na lang po na ako ni siya isa-isahon kids ha. Let's go directly to your Excel. Now, supposed to be, ang ako ang gusto buhaton na ni kids is to show you exactly your Excel. But then again, medyo lisudan manggugo sa style na mag-switch from one application to another. So that is why what I did here in my discussion is that nagsi-screenshot na lang ako or nagpe-print screen sa aking laptop and then nilalagay ko po dun sa PowerPoint ko. Kaya actually for me it's easier. So as you can see here, going back, these are the data points or our data. I placed it here sa first and then press your Megastat. So, eto po. Click nyo po yung data and then dun nyo po makikita dito po sa farthest right si Megastat. Once you click Megastat, ito po yung makikita nyo na tab, then find the non-parametric test. So, once you find the non-parametric test, click and then nasa pinakauna po si sign test. So, click yung sign test nyo and then ang next nyan is this one. So, ito po yung tab na makikita nyo na po. Dito sa input range, ito po yung i-highlight nyo. Now, actually, hindi po mag-matter yung positioning kung saan nyo po nilagay yung data nyo. Ang importante is, na-highlight nyo po talaga lahat. So, ano po yung ibig sabihin ko? Pwede nyo ilagay yung dataset nyo dito ba sa letter G or pwede ba yung pagkakalagay nyo sa dataset nyo is pa horizontal? Walang problema. Again, what matters here is you are able to highlight all your data. And then, for this one, ito pong hypothesize, ito po yung hypothesized mean natin. So, di ba, dun po sa ating example, which is your snow cone sales, di ba, 40? So, that is why you write 40. Now, for this portion, we'll just leave it as is. Wala po tayong gagalawin dyan. Not equal lang po talaga yan. Then, press OK. Now, once you press enter, you will be directed to a different sheet. So, mapapansin nyo po yan kasi kung titingnan nyo po yung name nung workbook or yung bagong worksheet, may nakalagay po na output. Doon nyo po makikita lahat ng results na nirarun nyo po sa Megastat. So, yung gagawin ko lang po dito, actually, kinakat ko lang siya kay para malagay ko siya side by side to our data kung saan po natin siya nilagay. So, ganito po. As you can see here, nakasummarize na po yan lahat. Ano yung hypothesized value nyo, ano actually. Tapos, may tatlo po tayong above or greater than our hypothesized value. So, balikan lang po natin saglit. Ito po. Diba? So, just to verify if yung numbers po na na-point out ng ating result is tama. So, as you can see here, diba, dalawa daw po yung equal. So, if titingnan po natin, yes, tama, 1 and 2 are equivalent to our hypothesized value. And then, may tatlo lang po dapat tayong pluses. So, ano po yung may mga plus? Ito po, 1, 2, and 3. And the rest of our data is already less than our hypothesized value. O, diba? Ang galing-galing. So, ayan. Balik po tayo. So, ayan. And then, ito po yung total number. Yan po yung meaning ng letter N dyan. It is our total sample. Now, our next question would be, where will you look at your p-value? Since there are two here, you have your binomial and you have your normal approximation. Now, between the two, always look at this part, yung binomial po. With the normal approximation kasi, ang meaning po kasi niyan, yung not normally distributed po, yung not normally distributed po natin na data, we actually transformed it to become a normal distribution. May mga ganyan po kasi na ways. Then again, we will not be teaching you that one. It's kind of complicated and not that really related na din. or di na din ganun ka-important kumbaga in terms of our profession. So, yun. Wag po tayo dun sa normal approximation, dun po tayo sa binomial. So, our p-value here is 0.0075. So, what will be our decision? Is it to reject or not to reject our null hypothesis? So again, going back to our rule, if it is less than 0.05, then we need to reject our null hypothesis. So since this is less than 0.05, then we will reject, meaning hindi po equivalent sa 40. And as you can see here, diba, 36 ba ang ato ang tinuod na median here? Then it is true that it is not equivalent to your hypothesized value. O, diba? So that is how simple your single sample sign test is. Okay, so let's proceed to our next test, which is your Wilcoxon test. So what is this Wilcoxon test? Now, Wilcoxon here considers differences in magnitude by using ranks. If we try to compare Wilcoxon to sign test, si sign test kasi pinapakita niya lang yung difference. But in terms of how different, how much they differ, if it is great, kung great ba or dili nga na ka grabe ang difference nila, then si Wilcoxon test yan siya. So, dito lang po actually mag-differ in terms of the magnitude. Kasi si scientist, it does not mind the magnitude. It just show you the difference. But with Wilcoxon, other than difference, it will also present to you how great that difference is by still using your ranks. And there are actually two types of Wilcoxon test. So you have your Wilcoxon rank sum test and you have your signed rank. So careful with the name. Ang isa rank sum, ang isa signed rank. Now, the main difference between these two Wilcoxon tests is that your rank sum uses independent sample, whereas for your signed rank test, it uses dependent samples. But both tests are used to compare distributions. So mainly nag-differ lang po talaga sila as to what type of sample what type of sample do we have in our data. Now, before we proceed to explaining each types of your Wilcoxon test, gusto lang na ako i-emphasize ang difference between your independent and your dependent samples. So let us consider this one. Let us consider a drug company that wants to test the effectiveness of a new drug in terms of reducing your blood pressure. So ang gagawin po natin, may isang volunteer po tayo. Before administering the new drug, we will first get his blood pressure before giving the drug. And then after a certain period of time, pagkatapos po natin makuha yung blood pressure niya, bibigyan na po natin siya ng drug. And then after a certain period of time, we will get again the blood pressure of that same individual. Now, from this example, will you consider this as an independent or a dependent sample? The answer would be dependent sample. Now, why is it dependent? Dependent siya, it's because the two samples that we have are taken from the same individual. And usually, dali ra kaayo gyud i-discover if ang inyuhang data kay dependent kay ang pinaka-common jud kaayo aning dependent na sample is kani jud before after na tests. How about independent? Independent kids, independent na sample ni siya if we have two different groups. One group will be given your active drug and the other group would be given the placebo. And then both will take the drug and then after some time, kukunan din natin sila ng blood pressure. So as you can see here, this is an independent sample because yung measurement, yung blood pressure na kinuna natin sa different na individuals. So, ganyan lang po. Independent and dependent. These are two different ways in terms of how we could actually perform our experiments. Depende na din po yan sa inyo kung gusto nyo na different na group or kung gusto nyo na same na person. So since we already explained what is independent and dependent samples, so now we proceed with our first type of your Wilcoxon test, which is your rank sum test. Now, your Wilcoxon rank sum test is more known, mas kilala po siya, being your Mann-Whitney test or sometimes your Mann-Whitney U test. But mostly in the different softwares, usually yung nilalagay nila, Wilcoxon Mann-Whitney. Ganun po siya. So, it is the non-parametric equivalent of your independent t-test since, as mentioned, for your Wilcoxon rank sum test, what we are using here are independent samples. So it uses ranks to determine if two independent samples were selected from populations that have the same distributions. So what we usually do here in your Wilcoxon rank sum or your Mann-Whitney test is that we rank all of your data and then compare the sum of the ranks for each group to determine whether the groups are the same or not. So kung atuwa man ni siyang Bisayaon, atuwa sang irang tanan data, kwaon nato ang iyahang average, o i-sum up nato ang katong na ranks, and then atuwa dayong i-compare ang dito sa duha nato ka grupo kung same ba sila or dili. So nga na, di ba? Naatay mga translation diri ah. So bale, what will happen now? Once we rank and we sum the ranks of each of those groups. Now, when the ranks are summed for each sample, and the sum should be, kumbaga, and yung sum nyo is approximately equal or actually equal, then your null hypothesis will not be rejected. But if there is a very large difference in the sum of your ranks, then in short, your distributions are not identical and your null hypothesis will be rejected. So, I will just repeat that again. If the sum of your ranks for each group are approximately equivalent, then the null hypothesis will not be rejected. If there is a large difference in the sums of the ranks, then that would mean that your distributions are not identical and your null hypothesis should be rejected. Okay? Parang ganun. But then again, malalaman for you to have an easy way of interpreting and making a decision, p-value pa rin naman yung titingnan natin. Sa sinabi ko kasi kanina, it's mainly a rule when you are doing manual computations. Okay? Then again, kailangan nyo pa rin yung tandaan. So, what are the assumptions for your rank sum test? So, number one, two samples, size and M, have been independently and randomly drawn from the respective population, but in simple terms, it should be independent. Your measurement scale is at least ordinal. Your variable of interest is continuous. If the population differ at all, they differ only with respect to their medians. So yun, dapat with respect lang to the median. And in addition to that, in addition pa di ay, in terms of the assumption, your sample size, kani isa pud ni siya sa dapat natukpan, it should be equal or greater than 10. So kana na siya. So let us take this one as an example. Times to complete an obstacle course. So let me just read the problem. Two independent samples of Army and Marine recruits are selected, and the time in minutes it takes each recruit to complete an obstacle course is recorded, as shown in the table. At level of significance 0.05, is there a difference in the times it takes the recruits to complete the course? So we are given the following data, and this will be our null and alternative hypothesis. So as you can see for the null, diba mamo dyan yung usual na kanang linya nato kung mayuntag null hypothesis. So for the null hypothesis, there is no difference in the times it takes the recruits to complete the obstacle course, whereas for your alternative hypothesis, there is a difference. So how do we process? How do we compute for the p-value of your Wilcoxon rank sum? So this is your step-by-step. Nilalagay ko lang po talaga ito kids so that ma-follow nyo along the way or kumbaga kung may nakalimutan, then meron lang din po kayong procedures na titingnan. Then again, we'll go directly to this one. So this is how I placed my data sa Excel. So here nakalagay, ito po yung sa Army, ito po yung sa Marines. Then yan na kaagad yung ating data points. So the same as usual, you click data, you click the megastat found at the farthest right, and then click on parametric test, and then you will find there Wilcoxon Man Whitney. O, diba? Wilcoxon Man Whitney. So, namali lang to siya kids. So, diretso ta dire. So, upon clicking the Wilcoxon Man Whitney, ito po yung lalabas na tab. And then, sa nakikita nyo dito, may different groups kayo. So, for group 1, you highlight all the data points under Army. For group 2, highlight all the data points from the Marine. And then, you check here, kaning output rank data and correct for ties. Kaning continuity correction, dili kay nato ni siya ginagamit. As what I have researched, continuity correction is usually applied when you want to use a continuous distribution to approximate a discrete distribution. Or kumbaga, it is used when you want to use a normal distribution to approximate a binomial distribution. So yun na yung same sa ating sign test na may normal approximation tayong ginagawa. And since we do not do that one, then we will not take continuity correction. Correction for ties, literal, na kumbaga, if in case may mga tie or same numbers tayo, then i-correct niya. As to output rank data, ito po yung sinasabi ko na automatic na si Excel ang magra-rank sa data nyo and ipapakita niya kung paano siya na-rank. So, wala po tayong gagalawin dito na part. Ito lang, check output rank data, check correct for ties, and then you just click OK. So let's proceed. Now, once you click OK, again, kids, ida-direct po kayo dun sa output. Then again, the way I present it here, print screen ko siya kaya para side to side ko po siya sa ating data. Yan. So, the first thing that I want to show you is in terms of the ranking. Kasi nga, di ba, naka-check yung ating output rank data. So, ganito po siya. Yung nakikita nyo po dito na side, ito, this one, this is the rank data created by your Excel. This one is the rank data from the book. So, i-check lang natin kung tama. Just to double check if Excel correctly ranked your data. So, as you can see here, yung number 1 natin is this one. Again, from lowest to highest kasi yung ginagawa ni yung pagre-rank natin dito. Now, our lowest value is from the Marine group in which yung time niya is 8. So, as you can see here, Marines 8-1. Even here sa book, 8 Marine 1. And then yung second natin, saan ba yung second? Dili na ko makla. Ito. This is the second. Still sa Marine po na group. And then siya ang second. So, di ba? Di na nato na siya isa-isahon kids ha. Basta, as you can see, sa first two pa lang, it is already correct. So, as you can see here, ito po yung label. So, sunod-sunod lang na siya. Na kumbaga, una ang tanan Army. So, you can see here, all Army, then all Marines. And even yung data dito, ito po yung data na nilagay natin. So, Army na 1 is 15, di ba? 15, 18, 16. So, sunod-sunod lang. So, dito na lang po. Siyempre, kung may mga ties, kaya po may mga 0.5 kayo na nakikita. So, ganun po. Next. And then, ito na po yung result natin. Other than the output rank data that will be shown by Excel, meron po kayong makikita dito na summary din. So, ito, kumbaga, parang naka-table lang na total number for Army, di ba, may 12, and then for the Marines, may 11 po, and then may expected value tayo, but of course, the most important one is your p-value. Just to point out also, Mado-double check nyo po if you really check for the correction for ties kasi dito po nyo siya makikita ito. Z-value corrected for ties. Kung di po naka-check yung corrected for ties nyo, then wala po kayong makikitang corrected for ties dyan na word, just the letter Z or Z-value, ganun. So as you can see here, our p-value is 0.162. Yan. Our p-value is 0.162. So since it is less than 0.05, then we will reject our null hypothesis. So meaning may difference po yung time it takes for the recruits to complete our obstacle course. O, diba? Very easy. Charot. So now we proceed to our next type of Wilcoxon test, which is your signed rank. So signed rank test is actually the non-parametric equivalent to your paired t-test for your dependent sample. So it tests whether two dependent or related samples, matched samples, or repeated measurements on a single sample have been selected from two populations having the same distribution. Kumbaga kids, ako lang yun siyang gibutang tanan because pwede man gud ni nato siya ipang interchange pero same lang yun sila og meaning whether we mention dependent, related, matched, they all mean the same thing. Okay? So mo na ayaw mo ka confuse basi manggug makalimot na dayon mo kung yung kog matched ang atong sample. Hala unsa man na independent ug dependent lang man tong na-discuss, di ba? So again, dependent, related, and matched samples mean the same thing. And these are our assumptions. So for our assumption, your sample should be random and your variable is continuous. Population is symmetrically distributed about its mean and your measurement scale is at least interval. And again, the best way for you to know if it is a dependent sample, usually it is a before and after test and it is using the same subject. So let's proceed to our example. So here, our example is about the shoplifting incidents. Ay, kung mag-ask tayo mo kids, asa na ako gikuha ang ako ang reference ha? For my discussion, this is actually a combination of different reference book, but the best that could actually help you if you wanted to read your book about the non-parametric test would be Bluman. Okay na si Bluman, very straightforward si Bluman, and dali lang jud kay siya sabton. Ana na kanindot si Bluman. Even in my examples, I am actually using Bluman since Bluman presented it well kesa sa uban akon. But then again, this is a combination of different references combined into one. So, for your shoplifting incidents, let me read. In a large department store, the owner wishes to see whether the number of shoplifting incidents per day will change if the number of uniformed security officers is doubled. A sample of 7 days before security is increased and 7 days after the increase shows the number of shoplifting incidents. O, diba? Before and after na test. So we have 1 week and then the number of shoplifting incidents before and after. So is there enough evidence to support the claim at the level of significance 0.05 that there is a difference in the number of shoplifting incidents before and after the increase in security? And this will be our null and alternative hypothesis. So there is no difference in the number of shoplifting incidents before and after the increase in security. There is a difference. So let us see. May difference nga ba or wala? So as usual, diretso, data, megastat, click ng parametric, and by this time around, yung makikita or dapat i-click nyo, yung signed rank. Kanina, si Wilcoxon Man Whitney for your rank sum. Kay signed rank, yung signed rank mismo na word, yung makikita, or yung makikita nyo. And then this is how I wrote my data. So, andito po yung day, yung before, and then yung after. Now, once you click the signed rank test, ito po yung lalabas. So, still, you have your group 1 and your group 2. So group 1 is your before, group 2 is your after, and then check for output rank data para makita po natin yung ranking, and then check for correction for ties, and then ito as is, then you press OK. So ano po makikita nyo na result? So since we have fewer data lang, so muna na nabutang na ako siya og isa. So as you can see here, so ganito po, you might ask, ma'am, what happened to the data? Bakit hindi po siya same sa data na nakalagay dito po sa ating example na may before and after? Now, here in your Wilcoxon signed rank test, what we usually do is we subtract before to after, or kumbaga in general, we subtract group 1 to group 2. So since we place group before, kaning before na results ninyo kay group 1, and then si after na results ninyo kay group 2, then nga niya mahitabo. So as you can see here in our data, diba, sa kay Monday, 7 and 5. So what happens here is we subtract 5 from 7, 7 minus 5. Then we get the number 2 here sa atong data. And then the same goes. So muna kung makita ninyo na ay negative kay diba nabi uban din just like kaning sa Tuesday, 2 minus 3, then that is negative 1. And then sunod-sunod na dayon na siya. And then lowest to highest gihapon ta, since na may duha ka negative 1 being the lowest, so muna na 1.5 1.5 ang ranking. Diba? So ingana na siya sa inyuhang Wilcoxon sign rank test. So again, di kay lang yun ninyo ma-appreciate manggud ang ranking kay di manggud ta naga manual na pag-compute. But if you are curious as to unsa gyud ang manual na computation, you can actually look at it kay Bluman gihapon. Gwapo gihapon kay ang pagka-present ni Bluman ana sa manual computation. O di ba? At least kids nakatakas gamay sa kung unsa kalisod mag-compute ug mag-memorize og mga formula. So pasalamat ta na natin mga ingani na software. Even sa atuang kung face to face pa ni siya di man gihapon na mo ipamanual og compute. Gamit yun ta, mas gwapo gani unta tong face to face, di ba, kay SPSS yun unta to mong i-introduce sa inyo ha. Then again, ana lang, adjust lang ta sa diri sa atuang online classes. So, for your p-value that is 0.0411, so going back to our hypothesis. So since 0.0411 is less than 0.05, then we will reject our null hypothesis. So dun po tayo titingin sa ating alternative. So meaning to say that there is really a difference in the number of shoplifting incidents once na double yung ating security. O, di ba? Okay. So that is Wilcoxon sign rank. Next. So now we go to your fourth type. Di ba na natay single sample sign test, Mann-Whitney, sign rank. So now we have our fourth type, which is your KruskalWallis test. So what is this KruskalWallis test? Now, KruskalWallis is sometimes called as your H test, and it is the non-parametric equivalent of your one-way ANOVA. O, sa inyo hang ma-remember sa ANOVA. 'Di ba? Sa tanan-tanan siguro kids, kung ako ha, pinakadali kayo tandaan si ANOVA o KruskalWallis. Why? Because the number of samples for your KruskalWallis and your ANOVA is that it has 3 or more samples. O di ba? Pagtanaw pa lang ninyo sa inyong data niya, daghan kaayo mo og categories ay alam na kung unsa ang gamiton. Basta 3 or more samples na gani gyud na KruskalWallis or ANOVA na dayon. Okay? So, again, your KruskalWallis is used to determine whether 3 or more samples came from populations with the same distributions, and that the assumption for your KruskalWallis is that it is not normally distributed and your variance do not have to be equal. Kasi nga, di ba, kay ANOVA from the name itself, kay ANOVA, which is looking at the variance, normally distributed na siya, ang variance pag yun niyang equal. So, of course, if dili na ma-met na assumption, then you use your KruskalWallis. And also, another assumption for your KruskalWallis is that the sample size must be 5 or more. So, remember ning last two. Again, mo ni siya ang assumptions nato na dapat tandaan for your KruskalWallis. So let's proceed to the example for you to understand better and to know how to do Kruskalwallis testing in your Excel. So we have here your hospital infections. Let me just read. So a researcher wishes to see if the total number of infections that occurred in three groups of hospitals is the same. The data are shown in the table. At level of significance 0.05, is there enough evidence to reject the claim that the number of infections in the three groups of hospitals is the same? So you have here groups A, B, and C, and then the number of hospital infections. So this will be our hypothesis. There is no difference. Null hypothesis, there is no difference in the number of infections in the three groups of hospitals, whereas your alternative, there is a difference. So for your Kruskalwallis, again, proceed na, diretso. Diri sa ato ang Excel. So, usual, click your data, click your megastat, and then mag-appear ni siya na tab. Then click ng parametric, and then you will find Kruskalwallis test there, which is this one. So, once you click that one, wala mo laing makita sa tab niya kung di isa lang, which is your input range. So, what you need to do is to highlight all of your data sets. Yung ana lang yun na inyong buhaton. And just make sure that it is properly labeled. Okay? So again, highlight everything. Check the output rank data, check the correct four ties, and then press OK. So, ano ang mangyayari sa result? Ganito lang din po yung itsura. As you can see, ito na po yung naka-ranking. And diba, kaya sinabi ko na properly label kasi nade-detect lang din naman ni Megastat kung ano yung label nyo sa taas. So yan, Group A, Group B, and then you have your Group C. Then you have your data value, and then ito po yung ranking from lowest to highest. And then dito po, naka-summarize, diba? Ano po yung median, ilan yung sample, yung total sample, ano yung average na rank, and then of course your group, and then dito po tayo titingin sa p-value. So, our p-value is 0.0690. So, what will be our decision? So, our decision would be, since it is greater than, diba? Greater than 0.05, then we will not reject the null hypothesis, meaning to say, there is no difference in the number of infections in the three groups of hospitals. So, di ba? As easy as that. Okay. So, we'll cut our discussion here. Kay murag taas-taas na po, naka-reach na ata ta og 1 hour. Sorry sa mga pachika-chika pa. So, break ta gamay, and then if ready na mo maminaw, then proceed to our next video lecture. Actually, naana lang man tay two parts. Oh, correlation and your chi-square. Under correlation, natay duha na i-discuss. Under chi-square, test natay upat. And then, done na mo dayon sa inyong nonparametric. So, thank you for listening in this first half part of our discussion. And I do hope you learned a lot. If there are questions, do not forget to post your questions in the content forum so that everyone could also see. Kay malay nimo, pareha day lang pud mong questions sa imuhang sa uban. So, thank you kids and rest for a while. Bye!